Now it's okay. Now what I want to point out here is three coils are there connected in series. So the first coil is 1/8 coil. Okay, so these are the three coils. In between they are connected in commutator segment as well. Okay, now this is how we'll have how many sets? 12 coil. That means we'll have 4 sets like this. Okay, now you see the 512 coil is connected with another coil. What is that number? Can you tell me? From this diagram, I am opening the diagram once again. And if you have yours, you just open it. And you just tell me that the 512 coil will be connected with which coil? What is the next coil to this 512 coil? Anybody? Let me check here. So this 512 coil is connected with 714 coil, isn't it? What is the next coil? Are you there? You are not responding.
916.
Okay, so it's a 916, isn't it? Next, 11,
1118.
18.
18.
Now 11, 18 again will be connected with which coil? 13,
1320.
1320.
then 15, 22,
1522.
then 17, 24.
1724.
1724.
Now this will be connected with 17, 24 will be connected with 19,
19
2.
2.
19
21, 4.
4.
And 23.
23 6.
Now this 23, 6 will be connected with which coil?
1.
1/8 coil. Okay. So this will be connected with 1/8 coil. Okay. So this is how all the, if I show that all the coils are connected in series in a circular way, but actually they are not connected in series, they are connected in parallel. So how to show that they are connected in parallel? That means how many parallel paths will be there? That is determined by the type of the winding and number of poles. As it is a lap winding and there are phone number of poles, so parallel circuit is already determined, that is 4. Okay, so then there will be 4 parallel paths. So how to show the parallel paths? So that we should understand clearly. Now, as I told you that the current will flow from upward direction. The current will flow from upward, that 5 to 12 coil to 1 to 8 coil. Now, what will be the current direction? If you can say that what is the current direction in the next path? Is it upward or downward direction? You can use your own sheet, or I can also open that. Okay, so the what is the next? But what is the current direction of the next path? Upward or downward? You just check it. Because has started with 7, isn't it? It has started with 7. You see, so next coil will started with 7. So it has started with 7. So in this way, these are connected like this. Now you see 7 to which 7 to 13. Okay, then 13, then 9 to 16. So that means if I show it here, so all these coils, so 7 to 14, sorry, 7 to 14 or 13, 7 to 14, 9 to 16, and 11 to 18. So can you tell me in which direction the current will flow? Upward or downward direction?
Downward.
Follow?
Upward direction.
Upward direction. So this is also upward direction, isn't it? Okay, so let us stop it and go back to this whiteboard. So that means here also I have to show the current in upward direction. So how it is possible? These two are connected in series and both the currents are in upward direction. How it is possible? Can you tell me?
একটা সোর্স থেকে যদি কারেন্ট যায় দিয়ে
So
দুদিকে
if
ভাগ
there
হয়ে
is
যায়
some
এরকম।
other feeder, isn't it? If there is some other feeder, then it is possible. According to the KCL, if this current feeds and then this current will be divided into 2, isn't it? Am I right? Are you getting?
Yes, sir.
So this is possible. So that means here you have to place some brush. Okay. Now you just check what is the current direction in the next path. That means this 13, 20, 15, 22 and 17, 24. This path. What is the current direction? Upward or downward?
ডাউনওয়ার্ড 13 থেকে 20 এর দিকে।
You just check it clearly. Which direction it would be? You just refer
Sir,
your sheet, your own sheet, and you just check it. It is upward or downward? Anybody?
স্যার 13 থেকে 20 দিকে মানে ডাউনওয়ার্ড হবে।
Is it so? So let us check the sheet by Orko. Okay, so it is started with which well 13, 20. So 30, where is the 13, 13? Okay, so this is the 13. So 13, so 13, there the path ends. The current
হ্যাঁ, ওটা
coming there.
ভুল বলেছি। এটা তো 20 থেকে 13 এর দিকে হবে।
Correct. So that means if I draw it here, I think I cannot draw. Okay, so let me draw it here. Okay, so if I draw it 13, 20, next 15, 22, and 17, 24. So here also the current direction will be upward, isn't it? Is it okay now? Everybody agrees that?
Yes, sir.
Okay, so here also the current direction in upward direction. Now again the same problem arises here. So that means here both the current direction in the same. Then there must be some node. There must be some node. Node means where more than 3 electrical branches are connected. So there will be a third path and the current will exit from that node. Okay, so this is how. And if we check it, the next one, that is the fourth parallel path, that is also will have the same current direction. Again another problem will arise here, that is the same current direction. So you will have the okay, and these two path will have the same direction. That means another brush will be placed there. Okay, and these two brush you can short it and make some terminal, and these two brush you make a terminal. Are you getting? So this is how you have 4 parallel paths. Each parallel path consists of 3 coils and having 6 coil sides. Like the first parallel path has 3 coils and 6 coil sides. What are the coil sides? Coil sides are 1, 8, 3, 10 and 5, 12. The second parallel path will have 6 coil sides, 11, 18, 19, 9, 16, 7, 14. So this is how there will be 4 parallel paths, and to collect the current we need 4 brushes. So that means in case of lap winding, the number of brush is equals to the number of parallel path. So is it clear? So each parallel path actually we can also draw like this. So we have 3 voltage source in each parallel path. So like this. Okay, and the current flows through it. Okay, now can you tell me that what will be the negative polar, what are the negative polarity brushes and what are the positive polarity brushes?
Sir, upper brushes are positive polarity brushes, the upper two brush.
That means you are saying this is positive and this is negative.
And this is negative, the lower. Yes, sir.
Is it so? Anybody has any other opinion? So if I now open Orko Probo Nondi, are you there?
Yes, sir.
Now you just check it what you have done. The brush you have connected with the coil side 1 and okay, so let us take 1, that is negative polarity, isn't it? So how we have checked that? Because in case of source, so that your confusion I have understood. So in case of source and load, the conventions are different. As it is a source, so therefore here the negative polarity. Okay, so when the current enters, that polarity will be negative, and when the current direction exits, that polarity will be positive, because you know in case of voltage source, the current flows from negative to positive polarity. Okay, have you understood? Unlike the
Yes, sir.
load, in case of load, like in case of resistance, this is positive and this is negative if the current direction is like this. So that is the error in your diagram. Have you understood, Orko Prabhu?
Actually, sir. Yes, sir. Actually, I had taken it to be load, so that was the problem. I had taken it to be a motor rather than generator. So
No, no,
that
no,
was the
no.
problem.
For motor also. For motor also. Okay, so you see, for motor also, whatever the voltage is generated, that will be generated in motor also. If you provide some external voltage to run the motor, that is the terminal voltage. But there also some voltage will be generated, that is equals to J by A P phi N. And in case of motor, that voltage which is generated in the machine itself is called the back EMF, because that acts in opposition to the supply voltage, terminal voltage. Have you understood?
Yes, sir.
Okay, so for motor also the convention will be same. The polarity will be same.
Sir, can you explain this once again?
Which
But
point?
sir, I am trying to.
So
Sir, I
the
am trying.
polarity
Okay, you
the load
see. So generator, how you denote by symbols. So suppose is a shunt. Okay, is a shunt generator, shunt DC generator. Now this is your armature voltage. So this is your armature voltage EA, and this is your voltage VT, isn't it? And how you get the VT, that I have told you that in case of this generator, I don't know why this is hanged. Okay, so in case of this VT, so in case of generator, this VT equals to EA minus IARA. So that means as if one voltage source is there, EA, and in series with a resistance, as if you can simplify like that, as if there is a resistance RA through which the armature current is flowing. So this is the armature current, and we are getting this VT. Okay, now the same thing is applicable for motor also. What is the difference? Difference is the current direction. So that means in case of motor, okay, so in case of motor, also this EA will be there and RA will be there. What is the change? Change is the only the current direction. Only the current direction is the change. Okay, so this is your IA. Now here we have to write what you have to write, because here you just see the polarity. Here you see the polarity. Okay, have you understood? Now in case if we consider the polarity, here we will get V2 equals to EA plus IARA. So that is the difference.
Sir, I have a question.
Uh,
Sir, then in the above diagram, you have drawn negative in the terminals from where current is entering the coils. Then that is for the generator mode in the above diagram in the green
uh,
green one.
uh.
Then that must be for the generator mode, not the motor mode.
Which thing you are telling? Okay, so this one.
The green. Yes, sir, the green one.
Okay.
We
No,
not for
green
the red
one
one
just
anymore.
green
Then
one just
those
the
two
better
are
the
for the
voltage source I have just represented like this. I have just represented like this. I can also draw the
but
coil
for the
because
motor. Sir, sir,
no,
my
no,
question is
actually these are the
in the
coils. I
green
have
one.
just represented like this.
The
These are the coils. I cannot represent
okay, but the
actually.
current
বলো বলো আমি শুনছি।
my question is for the motor the current for the motor the current direction must be from the voltage source. I mean the from the voltage source terminal plus towards the minus for the motor mode.
Mhm.
But here you have done opposite. I mean here you have done for the generator mode, isn't it?
Which one? Okay, so this particular figure for
The green one. For generator mode I am saying it is also for the generator mode, the green one.
green one for generator mode only because in his diagram he was
Yes,
drawn
yes, yes.
generator, but
Yeah.
for motor it will be different.
Yes, sir. Okay, sir.
Sir, that was what I was yet trying to tell you. What you just said. Swastik just.
No, you have shown the generator, na? But inside you have shown the motor.
No, no, sir. I have shown both. Yes, sir. I have shown both actually.
But,
The generator outside. That's a direction.
Okay, so but one at a time you can take, na? How you can take the both? So you just check it because the current direction is not same and is not right. If we take this as a generator, your current direction is not right as I explained. Okay, so you just check it. Or Prabhu, you just check it. Your current direction is not okay if you take the operation as generator because you have shown as a generator. Okay. Okay, so this is how we place the brush and between which two coil we should place the we should place the brush position, that you should check thoroughly. Okay. Now the next thing which I will discuss is the wave winding. If you have any doubt regarding the lap winding, you can ask me right now. And the another thing I missed here, that is the lap winding which I have discussed and which you have drawn is called the simplex lap winding. It's called the simplex lap winding. Simplex lap winding. Okay, because here you have seen that the winding pitch, sorry, that commutator pitch YC is plus minus 1 and winding pitch is plus minus 2. Okay, but for multiplex winding, like the duplex winding, the commutator pitch would be plus minus 2. So that means keeping one commutator, the coil will end in the next commutator, next to next commutator. So it will skip one commutator segment. So that is referred as the duplex winding. So this is how you can have also triplex winding. So this is how the multiplex windings are done. But I have discussed only the simplex lap winding. Okay. Now we'll start the wave winding. For wave winding, the relations are a little different, and for wave winding, the parallel paths will be distributed under all the pole faces. Like here, if you observe carefully that each parallel path, that means if we consider in this case, uh, like this parallel, first parallel path, that is 1, 8, 3, 18, sorry, 3, 10, and 5, 12. This is a particular parallel path. This is under a particular pole face. Under which pole face this parallel path exists? Can you tell me? Under which pole face is there? It is there. Is it north or south? You just check it. Bolo? Would I
Sir,
ask
first
you?
one is under North Pole.
First one.
Yes, sir, the first parallel path.
Have you checked it? Then it will be south, it will be north,
Yes,
and this
sir.
is the south. Isn't it?
North, south.
They have the first one you
Yes,
have to
sir.
check properly. Otherwise the total thing will be wrong. So let me check this diagram. Okay, so the first one, that is 1, 3, 5. These coils. So if they are in an okay, so that is also relative one. If that comes under North Pole, then the next. So here they are in between, not exactly under the North Pole. They are in between, isn't it? Because here the upper coil sides are under North Pole and lower that bottom coil sides are under the South Pole. Okay. So anyway, so that means one coil set of coil sides are under one particular pole face. Another coil sides under the different pole face. But that is not the case for wave winding. For wave winding, all the parallel paths comes under, or rather all the parallel paths are distributed uh, distributed throughout the. Okay, so let me share it again. Okay, so all the parallel paths are distributed. Distributed means they are distributed under all the pole faces. Okay, so that is the difference. So let me draw a simple diagram, then you will understand it better way. That suppose I have a North Pole, then South, then again north like this. Okay. Now for wave winding, so how it will look like? So this is one coil. Okay. That will be connected with the next coil. So that means if these two coils only constitute one parallel path, okay, then this will be distributed. So another pole phase you can also draw here. Okay. So like this. Okay, so it's kind of wave. It's not a lap. So lap means the bottom coil side will return back to under the same pole, but it is distributed and it is going to the next pole. So that means one parallel path will be distributed under all the poles present in the machine. So this is how we'll draw the. So here we have the commutator segments. Okay, here if we have segment 1, okay, suppose under some other segments like 14, it will return back. Okay, and if suppose this is 1, then it will be 14. So the next coil will uh, start from here. It start from 2, and suppose this is your 3, that will be 16. So this is the coil number 2, and suppose this may be coil number 13. So this is how the wave windings are done. Okay. Now let us take some example. Otherwise, you will not understand clearly. So let us go for some example. Okay. So before the example, I will show you that what is the formula used for the wave winding. So the same back pitch formula is also applicable here. That is a YB. Can you tell me what was the YB formula? Anybody? Unmute yourself.
QC by P plus minus K.
2C by P
C
plus minus K.
plus minus K.
So the same back pitch formula will be applicable here. Okay. Now here the difference is difference in the commutator pitch. What was the commutator pitch expression for was there for simplex lap winding? Commutator
Plus
pitch
minus 1. Simplex lab.
was plus minus 1. Okay. Now here it is different. It is C plus 1, or rather plus minus 1 by P by 2. So that is the formula for the commutator pitch for wave winding. So that is the difference. So for wave winding, this is the difference. The commutator pitch is different. So as you can see here, that commutator segment, the commutator pitch is quite different. Okay. And what is the winding pitch then? What is the winding pitch? If this is the commutator pitch, then what is the winding pitch? You can use your knowledge for simplex lap winding.
Sir, back pitch plus front pitch.
No, front pitch I've not calculated it. Front pitch is always back calculated. Before that, you should know what is the winding pitch. Okay, so winding pitch is always 2 times of the commutator pitch. Okay, so this is twice C plus minus 2 divided by P by 2. So this is the formula for the winding pitch for wave winding. So that is also different from the simplex lap winding. Okay, and you can understand for duplex wave winding, it will be C plus minus 2, and here it will be twice C plus minus 4, like that. Okay, so that will be the change for wave winding. So this is this I am discussing only the simplex wave winding. Simplex wave winding, not duplex or triplex. This is only simplex wave winding. Okay, now just write down a problem so that I can discuss with this problem and you will understand it a better way. So draw the winding diagram in radial form. Draw the winding diagram in radial form for a 4-pole. Should I write it? Okay, let me write that. Otherwise, so draw winding diagram. Diagram in radial form for a 4-pole 13 slot simplex wave uh, winding for a DC generator having 13 commutator segments. Okay. Now it's a number of, okay, so that also number of coil sides per slot is 2. Okay, so this you have to draw. Have you written the problem? So what is the number of coil?
13.
Again the same thing. So that is half into 2 into 13, it is 30. So as I discussed in the last class. Okay, what is the number of coil sides? Because
26.
that is important for your winding design. It's very important for winding design. So it is 26. So that means 1 to 26, the coil sides will come. Now, what is the next important for winding the design? Can you tell me? What is the next parameter?
Slot per pole. Slots per pole.
Okay, slots per pole, but that is not very important for winding. Anyway, we can also write that slot per pole, but here it will be fraction. How many poles? So 13 slots by 4, isn't it?
Yes.
So that means
3.25.
okay. Now, next thing which we have to determine related to winding, armature winding,
Back pitch.
back
Back
pitch.
pitch.
Okay, so back pitch. Back pitch, you know the same formula twice by C, na? By C by P
Hmm.
for progressive, we should take. Okay, anyway, for plus K you just take, minus also we can take. Okay, so if we take plus K, what will be the back pitch here?
7. If K is plus half.
So it is again 7. So similar to the earlier case. So it is 7 again. Okay, because it should be the odd number, isn't it? Now,
Yes.
next, what we have to determine? Y.
Commutator pitch.
And what is the commutator pitch?
Hmm. C plus minus
Progressive
1
winding, C
multiplied.
plus. Progressive winding, it is C plus. So this is 13 plus 1, 4 by 2. So 14 by 2, that means again it is also 7.
7.
And what is the winding pitch?
Yes.
Y is into YC,
14.
it is 14. So these are the all parameters which we have to determine before going into the winding diagram. Okay, so before going to the, now you can also calculate your front pitch because that is not very important for any winding. So what will be the front pitch? Huh? Can you remember that?
Sir, 7. 7.
Okay.
Yes, sir. YB plus YF equal to Y.
For here it is different, isn't it? So it is 7.
Yes, sir.
Okay, for winding that will not be required for winding as you have seen for this winding table. For winding table as we have drawn uh, for the simplest slab winding, the important things are the back pitch and the winding pitch. Commutator pitch also will not come because the commutator pitch will come only in case of the radial diagram that we have drawn in the drawing sheet A3 paper. So then the commutator pitch is important one, but as far as the winding table is concerned, only the coil sides are written there. There you need only the back pitch and the winding pitch. So let us start the winding table. You just start. So winding table. So first I will start with 1. What is the next one? What is the next one?
8.
So here the
8.
back pitch will come. What will be the next one?
15.
Correct. So here your winding pitch will come. 15. So here your back pitch will come. Again the back pitch will come. And back pitch is 7. So that means it is 22.
20.
Again what will come? The winding pitch.
4.
হ্যাঁ ভালো করে বল
3.
3.
4 কি করে হলো? So it
3
will be
হবে
3.
স্যার।
It will be 3 only. Okay, so next one is again it's simple 3 plus 7. 3 plus 7 it is again 10. Okay, again what will come? 3 plus 14.
17.
17. The next one 17 plus 7. So again the back pitch will come
20. 24.
24. Okay, so let me ask now somebody else. Let us check whether you are attending the class carefully or not. Raisha Chatterjee. Raisha Chatterjee.
Yes, sir.
Okay, so
Hello.
you are there today. So in the last class you are not there,
Yes, sir.
though your name was showing in the participant list.
Sir,
So
sir, my internet.
Okay, so you have some internet issue. That is very common thing. But today you just tell me that what will be the next coil site just after the 24. Just after the 24, which coil site will come?
Sir, 1.
Why? Why 1? You see, after 17, again you have to calculate the y. What is y? What is the value of y? Raisha, what is the value of y? It's just written on the board. What is the value of y?
Sir,
14. Isn't it?
hello.
হ্যাঁ শুনতে
Sir.
পাচ্ছি বলো বলো শুনতে পাচ্ছি
Value 7.
হ্যাঁ 7 37
Y is to 7, Y 14.
হ্যাঁ
14.
now what will be the next coil site that I'm asking? What will be the next coil site I should write here?
Sir, 5.
Why? Why 5? What is the explanation?
Sir, 26 plus 5.
26 plus 5. Where is the 26 value? So let me ask somebody else. Shayon Nag. Shayon Nag.
Yes, sir.
Now, what would be
Hello?
the next coil side? Can you explain
5.
why?
So it will be 26 plus, then it will go to 5.
20?
So 17 plus 14 it will be, then it means 26 coils, then it will go to 5.
I couldn't understand what you are telling. 17 plus 14.
So now, yes, so
Okay.
up to 26 it will count, then it will go to 5.
So why it is
Hello?
5? I couldn't understand. তুই কি বলছো আমি শুনতে পাচ্ছি না ঠিক। বলো দেখি আরেকবার।
হ্যাঁ স্যার, এটা হচ্ছে 17 থেকে আমি আবার যাব 14 অবধি, তো 26 এর উপর আমি তারপরে
17 থেকে
আবার
14
1
অবধি যাবে
থেকে
মানে বুঝলাম
কাউন্ট
না।
করব,
17 থেকে 17 প্লাস
মানে
14 তো।
অ্যাড করব।
হ্যাঁ, হ্যাঁ, অ্যাড করলে কত হলো?
হুম, তো 26 এর পর আমি আবার 1 থেকে কাউন্ট করতে শুরু করব।
ওকে। হ্যাঁ, সেটা বলো। So you are getting how much you are getting? You are getting 31, isn't it?
5. হুম,
Okay, so 26 plus 5, that you are saying. Okay. So it is 5 then.
হুম,
And the next one is very simple.
12.
12. So as simple as that. Okay, okay, next let me ask somebody else. দৈপায়ন গুহ।
Hello.
হ্যাঁ, দৈপায়ন।
Hello.
হ্যাঁ, I
Sir,
can.
19.
বলো।
19. 5 plus 14.
You are saying this is 19.
Yes, sir. 19.
And the next one
Sir, then 19 plus 7, 26.
is 6. Why you are saying this is 19? Can you explain?
Sir, because 5 plus capital Y. 19.
Okay. Is there any other
And
explanation?
then 19 plus YB, 26.
Okay, that is fine.
Sir, for which one?
So this you are saying this will come y, na? And this is yb. Is there
Yes.
any other explanation?
Yes.
No, no. I am asking, is there any other explanation?
Mm. So the pitch is constant throughout the machine, so it should be Y.
No, no, no. Is there any other explanation, Swarnadeep Saha?
Sir, I think yeah, from 12 to 19 the front pitch is 7, so
Correct.
if we add then we get 19.
So that means that we are missing. So as we have already calculated the front pitch, so here the front pitch will come directly because already we have calculated that. Okay, so either we can go
Yes, sir.
by this winding pitch or we can go by this front pitch. So like from the 26, we can directly add the front pitch because 7 is the front pitch. So that means the next coil will be 7 because 26 is the last coil side. So it will be 7. So the next one will be 14. Okay. The next one will be 21. Okay. The next one will be, sorry, 21 plus 7, 28. So that means it will be 2. 26 plus 2, 28. The next one will be 2 plus 7, 9. 9 plus 7, 16. So that means here front pitch, back pitch, front pitch, back pitch is coming. So this is front pitch. This is back pitch. This is front pitch. This is back pitch. Again, this is front pitch, and this is back pitch. Okay, so 9, 16. Then after 16, we have 23. Next, after 23, 23 plus 7, that is 30. So 26 plus 4. So then 4 plus 7, 11. 11 plus 4, 7, 18. 18 plus 7. 18 plus 7. I have some problem in my audio. 17 plus, okay, so 18 plus 7, how much? 25. 25 is there.
25.
Okay, so 25 plus 7, it is how much? 32. So 26 plus 6, so it will be 6. And then it is 13 plus 7, that is 30, sorry, 20, sorry, 6 plus 7, 13, 13, and then it is 20, then it will come back to the 1. So this is how the complete winding diagram is drawn. Is it clear? This is the winding table for the wave winding. Okay. Now, today I will give one more assignment for the next class. But these you don't have to draw in the drawing sheet. You can draw, but not necessary. You can also draw in A4 size sheets. But the problem will be different. Problem will not be the same. So you just change the number of slot and the commutator segments. You take it 15, and this is also you take 15. This 15 and this is 15, and other things that you can other things you can take the same. And what you have to do in this problem, again you have to draw the winding diagram and the diagram in radial form, the winding diagram in radial form that we have drawn in your assignment, last day's assignment. So these two things, and the third thing is this type of diagram you have to draw that I have drawn here. So this type of diagram, coil diagram, you have to draw with the brush position. Okay, so this type of diagram also you have to draw. So this type of, I don't know why this is not working. So this type of diagram you have to draw. So that is the third one. So these three things you have to draw in this sheet. First one is the winding table, second one is the radial diagram, and the third one is the uh, derived winding diagram, you can say. The derived winding diagram you have to draw. So these three things you have to show in my next, or you can submit in the next class. And those who have not submitted, uh, and I ask you to show it here, but due to some time constraint, it is not possible for all to show here. So therefore, I have changed my decision. So you just send me in my email. In one email, in the jadavpuruniversity.in email, you send your mail. Okay, so taking the image and making the PDF. You just send the email in my email ID. Okay. Now, if you have any doubt regarding this winding diagram for the simplex wave winding, you can ask me, or I also can ask you some problem.
Sir, regarding this assignment which you told just right now to draw what is the means last date of submitting or means
Okay, so last date of submission is the next class. Okay, so before the next class. So suppose if I take the next class on next Tuesday, then you have to submit by Monday. Because but in this week, I don't know it is whether it will be possible for me to take one more class because you have Chhat Puja this week, and for that Friday, Saturday there will be holiday. So I will take the class in the next Tuesday, I think. So the Monday is the last day of submission. Anything else?
and sir today those who have not submitted means
They have to submit
like me I have not
just
submitted
after
yet
the
the
class.
previous yes sir but
Just after this
okay
class,
sir
they
but
have
I
to
have to
submit.
go but I have to go to the cyber cafe for scanning so it can take some time sir.
Okay, so within today also you can submit today night.
Okay, sir. Thank you, sir. And sir, will there be any deduction of marks or something like that?
No marks deduction. So I will
Okay,
check
okay.
it then.
Yes.
But what you should do, except of these formalities, you should try it yourself because now it is very easy to uh, draw all this because it is a matter of second for your friend to send you the image. Okay, and it is also available over internet. I am giving you this type of assignment so that you can understand, you can understand the winding, how to make the DC machine winding for your benefit. If you don't want to do yourself, then you will not learn ultimately. So that is the problem. Okay. So whoever sent me by WhatsApp, I also check that. I also check that. I have not written down their name in due list. Okay, but whom I have not somebody assignment I have not received either in email or in WhatsApp. So that I have pointed out today, like Mousumi Shoren and
স্যার
the
তাহলে
other fellow.
আপনাকে পার্সোনাল মেলে মেল করব না ইউনিভার্সিটির মেলটায়?
University mail. ইউনিভার্সিটি
ওকে।
যাদবপুর ইউনিভার্সিটি ডট ইন যে মেলটা আছে ইমেলটা আছে ওইখানে আমাকে মেল করে দিন সবাই। হ্যাঁ, যাক এবারের মতো সবাই বিভিন্ন জায়গায়
ওকে
মেল করেছে আমি দেখেছি। আমি সবটাই নিয়েছি, কেউ হোয়াটসঅ্যাপেও পাঠিয়েছো সেটাও আমি দেখেছি, নিয়েছি, কোনো অসুবিধা নেই। কিন্তু আমার ওই যাদবপুর ইউনিভার্সিটি ডট ইন ওই মেলটাতে পাঠিও, তাহলে আমার পক্ষে কালেক্ট করাটা সুবিধা হবে। হ্যাঁ, কিন্তু তোমরা নিজেরা করো, সেটা সবচেয়ে বড় কথা। না হলে কিন্তু কিছু লাভ হবে না। হ্যাঁ, শেখাটা হচ্ছে বেশি দরকার। ছবিটা কমপ্লিট করাচ্ছেও। যদিও দেখে দেখে কমপ্লিট করলেও কিছুটা শেখা যায়। কিন্তু নতুন কিছু করার মতো ক্ষমতা তৈরি হয় না। তো এনিওয়ে, তো আমি যেটা আজকে তোমাদের কিছু কোয়েশ্চেন জিজ্ঞেস করব। So let me ask, I should ask. সময়িতা চৌধুরী,
Yes, sir.
সময়িতা, are you there?
Yes, sir. Yes, sir.
So have you understood the difference between the lap winding and wave winding?
Yes, sir.
Can you tell me the difference in their applications? In which type of application we should go for the wave winding, and for which type of application we should go for the lap winding? So suppose there are two types of application. In some application we need high voltage, low current, and in some application we need high current, low voltage machine. So can you tell me that which do you suggest? Which type of winding do you suggest for which type of application?
Sir, for low voltage, high current,
Yeah.
sir, we can go for lap winding.
Why?
And sir, in lap winding, the number of parallel paths is equal to the number of poles.
Okay.
So, sir, there will be more number of parallel paths.
Okay.
So the uh, net voltage might be low.
Okay. So that means you are saying that if we have the same number of coils, isn't it? Suppose if the number of coils are 12, and if we think of uh, a lap winding and wave winding, what is the difference? And suppose each coil is giving you some 10 volts. Then if the machine is 4-pole machine,
Yes.
now if I go for the lap winding, what will be the voltage? And if I go for the wave winding, what will be the voltage? Have you understood the problem?
The 4-pole machine has
Both the machine, wave winding
yes,
and lap winding,
sir.
is a 4-pole machine. Now if I go for the lap winding, what will be the voltage? And if I go for the wave winding, what will be the voltage? If I have 12 coils and each coil contributes 10 volts. It's a very simple question.
Sir, 120.
For which winding?
The lap winding.
How can you say that? You have 12 coils only. Okay, so let us go for somebody else.
So 12 coils and 10 volt. So then
Ah,
10 volt.
10 volts each. Each coil can contribute 10 volts only. And you have 12 coils in the machine. If we go for the lap winding, what will be the voltage? And if we go for the wave winding, what will be the voltage? If the number of pole is 4.
Sir, formula টা তো
There is a formula actually. You have to
2cn by a.
বলো।
So the formula is 2cn by a into pi m into p into eta.
You don't have to go in that details. If you think of this winding and how many parallel paths are created, then you can answer this. Now, in case of lap winding, how many parallel paths will be created? You just
Sir,
tell me
4.
4 because it's a 4-pole machine. So 4, you have to
4.
distribute your
Yes, sir.
12 coils into these 4 parallel paths. Then in what one parallel path, how many voltage source will come? How many coil will come?
So
In
3.
3. Okay, so that means 3 into 10,
So
so
3
30.
coils.
So 30. So each parallel path will contribute 30. So there will be 4 parallel paths which are contributing 30 volts. How many voltage you will get? All these
So
four
in
parallel
per path will get 30 volts.
30 volts only. So that means if it's a lap winding,
Yes.
you will get 30
Yes,
volts.
sir.
Now, if it is a wave winding, then how much voltage you will get?
Yes.
In wave winding, how
So
many
in
parallel
wave
paths?
winding there will be two paths.
Two paths.
So
Then,
there are two paths.
then how much voltage you will get?
So then per there were 12 coils or 6 coils into 10.
Correct.
So
Then
60.
60 volts you will get. As simple as that. You don't have to go for this formula ZA by AP phi n because you don't have all these parameters ZA, P, phi, etc. etc. Okay, so if you have the concept of the winding,
Okay.
you can answer this. For that means what you have started. That means you are saying that for low voltage the lap winding is okay. Lap winding can be chosen, and for this high voltage wave winding is can be
Yes.
chosen. So
For
you
high
can
voltage.
okay. So you can answer by this. You see the same similar machine, 4 pole 12 coil machine. If we go for wave winding, we can get up to 60 volts, and if it is a lap winding, we can go up to 30 volts. So that is lap windings are chosen for low voltage machine. And as there
For
are
low
more
voltage.
parallel paths, you will get more currents. In wave winding, only two parallel paths.
Yes.
Okay, so that means if each parallel path
Yes.
can carry suppose 5 ampere current, then wave winding will carry only wave winding machine will carry only 10 ampere, but a lap winding machine will carry 20 ampere,
Yes, sir.
isn't it? So that means lap windings are
Yes.
preferable for
Yes.
higher current, low voltage, and wave windings are preferable
And
for
low voltage.
lower the high voltage and lower currents. So wave winding,
High voltage and low
lower current.
currents.
Okay, so have you understood? So I think
Yes,
you have
sir.
understood this thing, where we should choose the wave winding, where we should choose the lap winding, and there are different types of winding. Is called the frog leg winding, where we use the mixture of these two, both the lap and wave winding. I will discuss that is not there in your syllabus in details, but still I will discuss a little bit regarding this frog leg winding in the next class. Now, another problem you have in case of lap winding, and that is due to the fact that I have just pointed out that for this lap winding, one parallel path comes under one particular pole, unlike the wave winding. Now, in wave winding, any parallel path is distributed under all the pole inside the machine. Are you getting what I am telling? In lap winding, under one pole, one parallel path comes. But in case of wave winding, one parallel path comes under all the poles. Okay. Now, if there is some mismatch in the poles, it is not possible to make all the 4 poles or 6 poles. All the poles are similar. It's not possible. Now, how this mismatch can come, that I can discuss later. But it is not possible to make all the parameters of the pole exactly same. So there can be some mismatch in the poles, in the north pole and south poles, all the north poles and south poles. Now, it may so happen that in case of lap winding, if there is a mismatch in the poles, in particular time instant, one parallel path will contribute more voltage compared to the other parallel path. Okay. Now take me this example where I have drawn all these parallel paths. Okay, so let us take this example. Now here I have a parallel path 1, 2, 3, and 4. There are 4 parallel paths. Now in the parallel path number 1, at this time instant, it comes, I have assumed that at a particular time instant, this parallel path 1 comes under the North Pole, parallel path 2 comes under the South Pole, like this. Okay. Now if there is a mismatch in these poles, so what will happen? The voltage contributed, the total voltage contributed by the parallel path 1 may differ from the total voltage contributed by the parallel path 4. Sorry, 2. So if that is the case, then what will happen if suppose, let us take a simple example. Suppose this is 2 volt and this is 2 volt. So how much voltage you will get here? Just quickly tell me.
2 volt.
2 volt.
2 volts only. That is our objective. So you will get 2 volt only. But if it is 2 volt and this is 2.1 volt, then how much voltage you will get there?
4.1 by 2.
Why? 4.1 by 2.
Because yes, sir.
No, it is very it is very
ইন্টারনাল
Yes,
রেজিস্ট্যান্সের
sir.
it
উপর
is not
ডিপেন্ড করবে
easy.
না?
It is not so easy to say
In-
that how much voltage will get across that. Anyway, but that will be
স্যার
determined by
ইন্টারনাল রেজিস্ট্যান্সের উপর ডিপেন্ড করবে না?
So that so therefore I am saying that it is difficult to predict how much voltage you will get there. So that will depend on the internal resistances of the voltage sources, but that is not provided. Anyway, if this is not provided, we can also take this as 0. But if it is the 0, then also how much voltage will come, we can find out. Anyway, but the problem will be you just check the problem. What is the problem in this? If this is 2.1 and this is 2 volt, there will be a circulating current. Okay, so who will drive the circulating current? The circulating current will be driven by this voltage difference. So there is a voltage difference of 0.1 volt. Now, in this circulating path, what is the impedance? Impedance is very low. The impedance or this resistance, which is provided by the voltage source, and purposefully that is that internal resistance or internal resistance or impedance of the voltage source is kept very low. Okay. Now, if this 0.1 arises in this circulating path, then that 0.1 volt is sufficient to flow huge amount of circulating current in this path, isn't it? So therefore this type of situation must be avoided. Now you come to this case when there is a mismatch in the pole. If this parallel path has a different value from this parallel path, so there is every possibility of circulating current in the voltage sources, to the voltage sources. Okay, and unnecessarily voltage drop, unnecessary power loss will be there. Because in case of DC voltage source, voltage drop is directly related to the power loss. Are you getting? So therefore, in case of lap winding, this type of problem arises. But in case of wave winding, we don't have this type of problem. Can you tell me why? Can you tell me why this type of problem is not obtained for this wave winding?
Sir, in wave winding, all the parallel paths come under the two parallel paths. They come under all the poles.
All the
So
poles. That means
the
if there
two
is a
parallel
mismatch,
paths are
if there is a mismatch
they'll
problem,
be
so that is
equal.
included all the parallel paths, isn't it?
Yes,
Because
sir.
there is only two parallel paths.
Hmm.
If there is a mismatch problem of the poles, so that will be included in the voltage source in all the parallel paths, তাই না? মানে কেউ কম কেউ
Yes,
বেশি
sir.
হবে না, এই কম বেশিটা সবার মধ্যেই আসবে, সব প্যারালাল পাথগুলোর মধ্যেই আসবে। Are you getting? Because here the parallel paths are distributed under all the poles. So that means if there is some mismatch problem of the pole, then that will be included in all the parallel paths. Okay, so therefore there will be no question of circulating current. But in case of lap winding, that is a problem. So therefore, what is done? We make some equalizer connection. Okay, so equalizer connection is basically uh, okay. So today's time is not there because already it is 17. So I will discuss this in details in the next class. Uh, so by this equalizer connection, we can avoid this. So how we do the equalizer connection, what is the equalizer ring and all, we'll discuss in the next class.